Hello again, Katie here from the Long Island Explorium. So the other day, a member of Team Explorium measured the circumference of a tree that was 538 centimetres around. In case you need to put that in context, an adult giraffe can sometimes grow over 500 centimetres tall. So that is a massive tree. The tree height measuring project was originally launched in September 2018 to coincide with the launch of a satellite called ISAT-2. Originally, the campaign was led by school students who took measurements using tools called clinometers to measure the height of the tree. In 2019, the app that we're using to measure tree height was launched, and the campaign was opened up to all citizen scientists of all ages all over the world. So the satellite ISAT-2, as well as a machine called JEDI, which, yes, you did hear that name right, on the International Space Station, work to record the surface height of the globe that they're flying over. This had been surprisingly tricky to do. It's obvious from Earth that a mountain is tall and a tree is less tall. But if you imagine a typical satellite image, the surface of Earth looks spread out like a blanket and pretty much as flat as a blanket too. So ISAT-2 and JEDI measure surface height by pointing laser beams down at Earth. So when this beam reaches a surface, be that the ocean, the top of a tree, an ice sheet in the Arctic, whatever it meets first on the way down, some of the photons will be reflected back up to the satellite and detected. By measuring how long it takes for the photon to reach the Earth's surface and come back, satellites can calculate the height of the surface the photon reflected off using the simple equation, distance equals speed times time. So the maths is simple, but the technology to get the measurements is certainly not. The satellite needs to measure the time it takes for the photon's journey to the nearest billionth of a second, which will let it measure differences in height of only a few centimetres, which is pretty impressive considering it's orbiting over 300 miles away from the surface of Earth. ISAT-2 was primarily designed to make measurements of ice at the poles of Earth, which is particularly important to keep track of as a way to monitor climate change. But it also measures tree height. Scientists use the tree height data collected by you on the ground to compare it with the data from satellites, and that allows them to improve their accuracy. So let's keep measuring trees, and I challenge anyone to find a fatter tree than the 538 centimetre beast our team member measured this week. I will see you all soon.